How do researchers use satellite data to monitor ice cover in polar regions? If you are curious about how scientists keep an eye on the ice in the polar regions, you are in the right place. Let us explore how satellite data plays a crucial role in this monitoring. Researchers rely heavily on satellite technology to track changes in ice cover. One of the key tools is Synthetic Aperture Radar, SAR satellite data. This type of data can provide high-resolution images of ice conditions, even in cloudy, foggy, or dark conditions. For instance, ICEYE's SAR satellite data can image large areas, up to 50,000 square kilometers, and even zoom in to areas as small as a meter. These satellites can monitor sea ice movements, locations, and conditions. They help in creating safe and efficient shipping routes by tracking icebergs and predicting ice movements. This is especially important for northern countries, where trade depends on shipping throughout the year. Another important aspect is the use of altimeters. Satellites like Cryo Sat-2, Sentinel-3, and ICE-Sat-2 use radar and LiDAR altimeters to measure the ice freeboard, which is the height of the ice above the sea surface. By using the hydrostatic equilibrium equation, scientists can calculate the ice thickness from this data. However, there are limitations, such as the need for precise snow depth measurements and the uncertainty in measuring thin ice. Satellite remote sensing also allows for the detection of changes in ice concentration, extent, type, and drift. Passive microwave sensors, like the Advanced Microwave Scanning Radiometer, and active microwave sensors, such as Synthetic Aperture Radar, provide continuous observations of sea ice parameters. These sensors can operate through clouds and darkness, making them ideal for monitoring large areas over long periods. To ensure accuracy, researchers often combine data from different sensors. For example, merging data from SMOS and Cryo, Sat-2 can improve the temporal resolution and reduce uncertainty in sea ice thickness measurements. In addition to satellite data, airborne and in-situ measurements are used to validate the satellite observations. The German Alfred Wegener Institute's Ice Bird program, for instance, uses electromagnetic induction and laser measurements from aircraft to determine sea ice thickness. These measurements help in understanding the biases in satellite-derived data and provide a more accurate picture of the ice cover. Satellite image pairs are also used to track ice drift. This can be done using correlation techniques or by tracking distinct features like ice flows, ridges, and cracks. These methods help in understanding the dynamic nature of sea ice and its response to weather and climate changes. Overall, the combination of SAR data, altimeter measurements, and other satellite sensors, along with validation from airborne and in-situ measurements, allows researchers to monitor ice cover in the polar regions with high accuracy and frequency. This is crucial for understanding climate change and its impacts on the polar regions.